All right, we're back. We're still on page 2, notes 15, Calc C. We are doing trig substitution. And so the next two that we're going to do are actually two that I would expect you to definitely not use trig substitution on. Like, I would expect you to look at this and say this is going to be like 1/5. Like, I'd expect you to rewrite this as 1 minus 6x over 5 squared. Then there should be a 6/5, so a 5/6, and then you're basically done, right? So this is going to be 1/6 inverse sine of 6x over 5 plus c. I expect you to be able to do that. Hopefully that's right. Here I would expect you to do 1 over 25 dx, 1 plus the quantity 2x over 5 squared. So like do them by recognizing. That's what the goal is. 5 halves here. So then this should be 1/10, I guess. And then tan inverse of 2x over 5 plus c. I expect you to be able to do them by observation. But in the event that something goes wrong with your observational skills, this method actually will work. So we can, we see a radical and we're not really sure. Golly. There you go. It's like you have to like definitely get it wrong for it to work, which doesn't really make much sense to me. But all right, I'm gonna put 5 here. I'm gonna put 6x here, and if I don't like it, I'll change it up. And then 25 minus 36x squared goes here. Here's theta. All right, so sine of theta is 6x over 5, which means x is 5/6 sine of theta, which means dx, because we have to sub for dx, is 5/6 cosine of theta d theta. And then our radical thing is cosine of theta is this over this. So let's say that 5 cosine theta is the radical. 25 minus 36x squared. All right, substitution times. What are we doing? We got this for this, and we have this for this. So, all right, integral 5/6, I'll take out cosine of theta d theta, then the radical is 5 cosine of theta. So kind of an interesting thing happens here. Well, I think it's interesting. The cosines cancel. You actually end up with just 1/6 the integral of d theta, which is 1/6 of theta plus c. And then what are we going to do with theta? Well, here, right? So here, so theta is the inverse sine of 6x over 5. So this will be 1/6 the inverse sine of 6x over 5 plus c, which if you compare, this is why like you should get it by observation. I guess by observation, substitution and observation, recollection. I don't know what the right word for that would be. That's how you should do it. You should do it the first way, especially in Calc BC. I guess Calc AV, you could also run into this, but well, probably not, but maybe. I don't know. If you're in Calc AB and you're watching this, it should be after the AP exam. So just know it for life. The next one's weird because there's no radical. So this is going to illustrate a really interesting technique that you can use. There's no radical, but there could be a radical if we rewrote this as the integral of dx over the square root of 25 plus 4x squared. And then how do I get rid of that? I square it. So that's crazy that you would even think to do that, but that's probably going to work. So let's see. Draw my triangle. It's like, it's so weird that it recognizes that. All right, so I'm going to put 2x here and 5 here, and radical 25 plus 4x squared. If you draw a triangle that makes sense for the radical, it's going to give you substitutions that are going to work. So you don't have to think about it too much. So let's see. Tangent of theta So I'm looking for ratios that involve only one variable. I don't want a variable in the numerator and denominator, just the numerator or the denominator. Preferably the numerator, but again, it doesn't really matter. So x is going to be 5/2 tangent, which is fine, but I don't need to substitute for that. I need to substitute for dx. So dx is 5/2 secant squared d theta. And then the radical, obviously. So the radical, this over this would be secant. So I'm going to say 5 secant of theta is the radical, 25 x squared. And I guess I will highlight, you don't really need to. Also, I got to sneeze like really bad. And I don't know, like, but I feel like the entire last video, I also needed to sneeze. And I was like, oh, I'll just like wait. And I waited, and then I like couldn't sneeze in the interim between the videos, and now I feel it again, and it's terrible. All right, let's substitute some stuff. So dx, I'm gonna take out the 5/2. 5/2, you get secant squared. So don't, like at this point, I would start getting nervous, but I'm gonna say don't get nervous. That secant squared, something's probably gonna happen. Down here we get 5 secant theta squared, 25 secant squared. So the secant squareds have canceled, and we actually have, this is 1/10 the integral of d theta. That's it. And this is starting to look an awful lot like this, isn't it? And it should, because that's the answer. So this is 1/10 of theta plus c. And then how are we going to get that? Oh, I crashed this. Did I crash this? I'm not convinced. Oh, no, I definitely did. Okay. So hold your horses. Crashed. Come back. Okay, plus c. And then, all right, so what are we going to do? So theta, I'm going to use, I always circle the wrong one. I'm going to use this inverse tangent of 2x over 5. So 1/10 tan inverse 2x over 5 plus c. And you can see by looking at it that this, that involved all this work, is the same as this, which required you to just kind of like remember. So it's better when it is, like if you know that this is AP calculus level material, you do not need to use trig substitution. Like at no point in time will you have to use it. But it's just awesome. And it all comes down to drawing a triangle. Like it's one of the easier substitutions because it's like based on geometry. So like we've been drawing triangles for years at this point to solve problems, and it's just another place you can do it. All right, I'll be back in the next video when we're going to start doing just an endless run of practice problems. It's not really endless. There's only 8, but like how long will that take? Who knows? All right, so I will see you in the next video.